Hi, welcome to this series of videos for students studying OCR 21st Century Science. This is the unit P5, which is all about electricity. And the purpose of these videos is to help pupils revise, to help pupils who are stuck with a concept, and also to help those pupils who've missed lessons on this particular topic. So we're going to start at the beginning with electrostatics. So we aim to cover in this video the structure of the atom, how we separate the charge using friction, what we mean by inducing a charge, and how these charges interact with each other. So you may already be familiar with the structure of an atom, but in our model that we use at GCSE, we imagine the atom to be a nucleus containing protons and neutrons. I'm going to represent the neutrons as dark blobs and the protons as red ones. And then the electrons are arranged around the outside in various orbital shells. This is not to scale. An electron will be whizzing around the outside. And maybe you could draw a better circle than me. So there might be two electrons in this shell. And we know that electrons are arranged in multiple shells. And we also know that electrons have what we have decided to call a negative charge. And the protons have a positive charge. And it should be fairly straightforward to remember the double P for protons being positive. And the neutrons themselves have no charge at all. And they simply add mass to the atom. So the mass comes from the centre, and when we look at P6 we're interested in the nucleus, but for electricity we're just interested in the electrons. Now, the idea of removing electrons seems to me to be a fairly obvious idea because the electrons are arranged around the outside. So if there is any friction between one material and another, it should be easy enough to remove these electrons simply by rubbing the material. Now, in certain materials, the electrons are easy to remove, and in static charging, we're dealing only with insulating materials. So there aren't any free electrons around, there are just electrons bound into atoms. So how do you induce a charge? So how do you charge a material? Well, in the classic case we might use a balloon, and we might rub it with a cloth. And by rubbing with the cloth, we can make things happen like sticking the balloon to the wall or lifting bits of paper and stuff. So what's actually going on here is very straightforward. The electrons, which remember are around the outside, if they are rubbed, then they can transfer from one material to the other. Now there is no need to worry about which way the electrons might transfer. You'll never be asked to remember if, for example, the electrons jump from the balloon to the cloth or the cloth to the balloon. It really doesn't matter. It's just the principle that counts. So let's imagine in this situation that the balloon has electrons removed from it. So what that would mean is that the cloth itself would gain extra negative charges because they're transferring from the balloon onto the cloth. So if the balloon has lost electrons, then it's losing negative charge. And if you're losing negative charge, then what you've got left over is an excess of positive. So if you lose electrons, you lose negative charge, which means you gain a charge which is positive. So the balloon might become positively charged if it loses its electrons. Now the cloth does the opposite. The cloth gains electrons So it gains negative charge, and therefore it ends up as a negatively charged object. I think it's worth pointing out here that we haven't created any charge. Both of these were neutral to start with, which means they both had the same number of protons as electrons, just like every atom has a matching number of protons and electrons. It's just that now we've transferred some of the electrons from the balloon to the cloth. So the cloth has extra electrons and the balloon has less electrons. So we have a negative charge on the cloth and a positive charge on the balloon. Now, because of the way that we have defined positive and negative, we have this situation where positive and negative will attract towards each other. So opposites attract in this case. And then likewise, if we have negatives near negatives, then they will repel just the same as if we have positives and positives. So opposite charges attract, but like charges repel. So what that means is that once you charge up these objects, then you can have things going on in terms of forces of attraction or repulsion between differently charged objects. Remember, all we've done is we've moved electrons from one place to another. And I think it's really worth remembering it's only the electrons that move, nothing else but the electrons. Okay, final part on here is about the idea of inducing a charge. Now, if I bring my balloon, which has got a positive charge, in this case, if I bring that near to a wall, now the wall itself is neutral, so it's got the same number of positive and negative charges. But when I bring the balloon near to the wall, what's going to happen is that the electrons are going to be attracted towards the positive charge. So lots of electrons will start to migrate towards the area where the balloon is going to be. Now, because we have then a lot of electrons in this place here, then the balloon will attract to those electrons and stick to the wall. Now, this is known as inducing a charge in the wall. The wall is still neutral and it hasn't gained any charges at all. It's just that charges have migrated, or electrons have moved towards that place to create an area here which is more negative. So an induced charge is when you have a neutral object, like a wall, which has electrons moving towards a charged area to create this area of negative. It does it because it's attracted towards the positives. Same would be true if the balloon were negatively charged. So imagine the balloon were negatively charged, then what would happen is lots of electrons would move away from this region, leaving behind the positive area, and the two things would attract towards each other. So that's how a balloon sticks to the wall. The positively charged balloon causes electrons to migrate towards the area, creating a negative charge, opposite charges attract, and the balloon sticks to the wall. Okay, just to recap then. Atomic structure. Electrons go around the outside of atoms and have a negative charge. We can remove electrons simply by rubbing. Because they're around the outside, friction will remove them and make them transfer one way or another from one material to the next. Opposite charges attract and like charges repel. And then this idea of inducing a charge, which means a neutral object can have a, if you like, a charge induced within it, or the charge separating. So one part becomes more positive than the other simply by the movement of electrons. Final point, it's only the electrons that move. Thanks a lot.